Hello there everyone, welcome again to the Royfit channel. Today this is episode 3 on our macronutrients playlist, and for our third video we're going to be talking about proteins. Now specifically we're going to be talking about your daily intake, the types of protein, the structures of proteins and the role they have in the body. Now then, we're going to start off with daily recommended intake of protein. Now for non-bodybuilding or exercise purposes, just your average Joe going to work, coming home, the referred nutrient intake is 0.8 grams times your body weight in kilograms. Now on average that works out as 56 to 88 grams a day for men and 45 grams to 64 grams a day for women. Now that's a sufficient amount. Protein should make up approximately 10 to 15% of your daily caloric intake. When it comes to bodybuilding, however, more protein is needed. So this works out as 1.2 grams or 1.4 grams times your body weight in kilograms. Now this is for endurance training, and it's a little bit more for bodybuilding. So 1.4 grams or 1.8 grams times your body weight in kilograms for strength training. Now people tend to think, the more protein you eat, the bigger you get, the stronger you get, the faster you recover. Now that's only true up to a certain point. Your body will never use more than it needs. So usually any intakes over 2 grams times your body weight in kilograms has been shown to have no significant improvements to growth or performance. Now, protein only carries 4 calories per gram, same as carbohydrates. Obviously, as I said in previous videos, fat is 9 calories per gram. Now then, you might be asking, what if you do consume too much protein? Now, there is no health or performance benefits to taking in more protein than needed. Your body will only use what is required. Now, excess protein is used as energy or stored as fat, the same as any other macronutrients we take into our body. Now, the nitrogen containing elements of protein can be turned into urea in the liver and is literally just flushed out in your urine. High protein intake can be dangerous to those with existing kidney and liver disease due to this transformation that happens in the liver. Now, high protein intake can also lead to accumulation of ammonia in the blood, which is toxic. Normally in cases of 2 grams or higher times your body weight in kilograms. Now then, the main function of protein. Proteins are the building blocks of life and serve many functions to keep our bodies and every other animal body alive and functioning. They are essential for growth, maintenance and repair of body tissues. They make up large structures of tissues such as ligaments, skin, muscles, tendons and hair. They also help with the making of teeth and bones. Now they don't only play structural roles, proteins also play in physiological functions inside the body. For example, enzymes. Now all enzymes are protein. Enzymes control the rate and pattern of all chemical reactions that take place in the body. Now this includes digestion of food and extraction of energy from it. Now here are a few examples of enzymes. There are absolutely thousands of enzymes in the human body, but these are just a few. Now first you've got lipase, a group of enzymes that help digest fats in the guts. You've got amylase. Now this helps change starches into sugars, and this is produced in the mouth and is found in your saliva. You've got maltase, also found in the saliva. Now this breaks the sugar maltase into glucose. Maltase is found in foods such as potatoes, pasta and even beer. Now you've got trypsin. Now this is found in the small intestine, and this breaks proteins down into amino acids. You've also got lactase, also found in the small intestine. This breaks down lactose, the sugar in milk, into glucose and galactose. Here we have acetylcholinesterase. Now this breaks down neurotransmitter acetylcholine in the nerves and muscles. Now we have helicase. Now this actually is important for unraveling DNA. Now we've also got DNA polymerase. This actually helps in the synthesis of DNA. Now there's a lot more to say about enzymes, if I'm honest, but I'm not going to go into that in this video, as I will make another video on it in the future. Now we're going to move on to hormones. Again, this is another very big topic. I will cover as much as I can on this video about it, but there will be another video on hormones in the future. So not all hormones are proteins, but some of them are. These protein hormones are chemical messengers that regulate activity of cells within the body and cover a wide range of functions, maintaining homeostasis. Now here are some examples of hormones. So we've got hormones of the thyroid. So the thyroid gland basically releases two hormones, so T3 and thyroxine, T4, which helps in controlling metabolism of our body. These hormones also regulate weight, determine energy levels, internal body temperature, skin and hair. For the second one, we've got insulin, one everyone fairly knows about. Now this is produced in the pancreas. Now this controls blood sugar levels from getting too high, so hyperglycemia, or too low, hypoglycemia. Next is estrogen. Now as you're aware, this is a female sex hormone. It is released by the ovaries. It is responsible for the reproduction, menstruation and menopause. Excess of estrogen in the female body increases the risk of breast cancer, uterine cancer, depression and mood swings. If estrogen level is less in female body, then it can lead to acne, skin lesions, thinning of the skin and even hair loss. Now we're going to move on to progesterone. Progesterone is a hormone. Again, it's produced in the ovaries in females, the placenta when a woman gets pregnant, and in the adrenal glands. So it's produced in 3 different places for 3 different things, so it's a very important hormone to our body. Now what this does is it stimulates and regulates various functions, including maintaining pregnancy. It helps the body prepare for conception, pregnancy, and regulates your monthly cycle. When pregnancy doesn't occur, progesterone levels drop and the menstrual cycle occurs. Now men also produce progesterone in their adrenal glands and testes. Now this is needed to make testosterone. In both it builds bone mass, takes part in regulating blood sugar and brain activity. We've got prolactin. Now this hormone is released by the pituitary gland after childbirth for lactation, which actually enables female breastfeeding. Levels of prolactin hormone rise during pregnancy. It also plays an important role in fertility by inhibiting follicle stimulating hormones. Some of you might have heard of these, FSH, and gonadotropin releasing hormones, GnRH. Now obviously we're going to have testosterone on this list. It is a male sex hormone, as you're probably aware of. It is an anabolic steroid by nature, which helps in building body muscle in males. It plays an important role in developing male reproductive tissues, testes and prostate. It also promotes secondary sexual characteristics like increasing muscle mass and bones, growth of body hair. And last but not least on our list, we've got growth hormone. Now this is also known as somatotropin hormone. It is basically a protein hormone that is secreted by the cell in the anterior pituitary. Now it stimulates growth, cell reproduction, cell regeneration and boosts metabolism, and is extremely important in human development. Now obviously that's not all the hormones in our body, because there are so many. Those are just some examples and just how important proteins are to us. Now, they also actually help in antibodies. Now, I'll make another video about the immune system because again it's such a huge topic, but I'll just talk about the antibodies now, as they are made up from proteins. So the antibodies released by our immune cells are made up of proteins, as I just said. T cells are comprised of peptide chains, which are small proteins, which are amino acids to attack invaders and foreign molecules. Now, these peptide chains of the T cells are then stored and remembered for future invasions. I will touch on that subject again in a later video. Now, we've got amino acids, the building blocks of all the proteins in our bodies. Now then, proteins are made up of long chains of these amino acids. Amino acids are organic compounds that contain amino, as you can see here, and a carboxyl functioning group, which is this one here, along with a side chain specific to each amino acid. Now, the key elements of an amino acid are carbon, hydrogen, oxygen and nitrogen, although other elements are found in the side chains of certain amino acids. Now, what are they important for? Well, they're important for the breakdown of food, for our enzymes. They're important for growth, so for our hormones, repair body tissues such as collagen, and obviously the building of proteins. Now, if you look here on our little amino structure here, you've got the R group variant. Now, the R group determines if the amino acid is considered acidic, polar, non-polar, basic or neutral. The R group can also help to predict the behavior and reactivity of an amino acid in a reaction. This basically determines what the amino acid is. Now, there are 21 types of amino acid the body needs. 9 of these are essential, meaning they need to come from an outside source, such as the food you eat. And here are all 9 of those essentials. Now, as for the other 12, these are non-essential, meaning that they can be made in our body cells from the right materials, and here are all 12 of those. Now, as you can see with this picture down here, these are literally just the structures of some of those. Now then, lastly, we're going to be talking about the structures of proteins. Now then, we have something called a primary structure. Now, the primary structure to protein is a linear sequence of amino acids in a polypeptide chain. This sequence is determined by our genetic code. We also have the secondary structure proteins. Now, this is where the sequence of amino acids fold into particular shapes. Now, what this does is it actually gives the chain more stability. Now, the two most common are alpha helix shape. So this is like a spiral shape that it gives. And we also have beta pleated sheet. Now, basically what this is just a row of lateral strands. Now, with these you have 3 backbones and they're kept together by hydrogen bonds. Now, as for the third one, it's called a tertiary structure protein. Now, this is actually a 3-dimensional structure, so a lot more advanced than the previous 2, that involves 2 or more secondary structure proteins. Now, they are held together by attractive forces such as hydrogen bonds or disulfide bonds. These structures will have one peptide chain called the backbone, enabling it to react with other proteins to form myoglobin. As for the fourth one, we have the quaternary structure protein. Proteins made this way are big, consisting of specific arrangements of many substructures in a very complex way, such as a globular structure and a fibrous structure. Now, these structures allow for different properties such as water solubility and fat solubility. Fibrous, as you can imagine, are long strands. Globular, if you can think about it, is like a spear. Now, as I just said, a protein's structure and shape affects its function. Now, as explained previously, there are 4 structures and 2 types. Fibrous, for example, are used to support tendons, skin and ligaments. This is because of the protein collagen. Globular is used for structures such as hormones. Now, as you can see here, I've gone and got a little photo. Primary structure being all strands. Now, this is the alpha helix, kind of like DNA, and beta pleated sheets. We've got the tertiary, which again is just twisted strands, and then we have the quaternary structure, which is all twisted together, many different structures all into one ball. Thank you for watching again today, guys. I hope you've all learned something new. Again, there are things in this video I will touch up on in other videos, as they are big topics. But as usual, please subscribe, hit the like button, and I'll see you in another video.